Gonna go through as promised. Four of you wanted me to go make a video on translating graphs. So again, translating graphs is one of those topics that requires a little bit of time for it to settle in your head, and obviously some time for you to get around the idea of translating graphs. Now, translating graphs is a topic that either if you have a graphic calculator will find it extremely easy. If not, you have to work really hard just to get your head around it. So when you're translating graphs, technically you have two ways you can translate. Two ways. So you got the first way and the second way. There's only two ways. Either you're going that way and that way. Either you're going up that way and that way. Let me just do that again. Either you're moving this way or moving that way, translating across the x-axis, or you're translating across the y-axis. So either you're actually translating across the x-axis sideways, or either you're going and translating the graph or the function up and down. And this obviously is for the x-axis and this is for the y-axis respectively. So it's when do you do this, and that's the big thing. We said that if we have a function f of x, and if in this f of x we have x plus 1 or f of x minus 1, because this is in the brackets, we move, okay, it's in the x-axis. However, because it's in the bracket, we use the opposite. So because this is x plus 1, we don't move it in the plus direction, we move it in the minus direction. And because this is x minus 1, we move in the plus. Because it's very, very similar to that of when we're solving equations. So if I take to solve x squared plus 4x plus, let's say 4, you solve, you say x plus 2 and x plus 2 equal to 0, and you tell me that the answer therefore is going to become x equals minus 2, because you took the inverse of what's in the bracket. Very, very similar in this state. We took the opposite. Here we're going to move it by minus 1, and here we're going to move it by plus 1. This is just an example. We're going to look into more detail. On this side, or on the contrary, we have this situation where we have, for example, f of x outside the bracket we have plus 1, and outside the bracket we have minus 1. In this, we do exactly what it says on the tin. If it says add 1, we push it by 1. If it says minus 1, we drag it back to minus 1. We do exactly what is on the tin. We don't do anything different. We do exactly the same, and we just stick with that. So if we, for example, apply this now to a question. So we looked at the first example we looked at was A. We looked at if we had a axis like this. Just draw my axis. I'm going through the entire work examples so that you have all of them here. You can slow down, you can speed up, you can do whatever you want. Okay, you can do whatever you want. We'll do them side by side so you have an easier understanding. Okay, so we have this situation like this. We said that our curve, our original function was x squared. So that's our original function, f of x is equals to x squared. They told us that we need to move this by well, if we take f of x and leave it as y, make it easy for you, we do the y is equals to x minus 2 all squared. Now x minus 2, that means that we are going to move this by 2 units, and because it is in the x-axis, we are in the brackets, we're gonna move it in the x-axis. But because it's minus 2, that means we're either gonna go this way or that way. But because it's minus 2, we are gonna go in the positive direction 2 units. So if we look at our point 0, 0, if we move x minus 2 that way, then we add to the x-axis. We do not touch the y-axis. We keep the y exactly the same. So adding 2 to here will give me 2, 0. And that looks like it's going to be about here. And our new curve is going to look something like that. I do apologize for my curve, something like that there. Now the question that we ask AS Maths is that what is this point here as well? We need to know that point. That point is the y-intercept. So if you expand this in your head, you don't expand it, you just take the last number. The last number would be minus 2 times minus 2, which is positive 4. So you can clearly see that the numbers on the x-axis is not on the y-axis is not changed, as this is 0, 4, and this is 0 and 2, 0. So, and if you think about it, at this point here, the point was, if this is 2, then here is going to be, well, in essence, if it's 2, 4, therefore we're moving it by 2 units, it's going to end up at this point, which is 0, 4. The y-axis does not change, okay? The y-axis does not change. That's very, very important to get your head around. So now we've shifted this in the x direction, we're going to shift this into another question into the y direction. So let's just rub this out. And let's retry this. Let's draw the graph, just the axes now. Let's change this now to that side. Now let's look at f. So xy is equals to x squared plus 2. Now this one is going to be plus 2. So if you go back to our notes, that anything outside the brackets are gonna be shifted in the y-axis, and we do exactly what it says on the tin. Okay, exactly what it does. That's a proverb in English. It means exactly what it says. Do exactly what it says. Here in the bracket, we do the opposite. But if it's outside like this, we do the basically exactly what it says. So plus 2 means that we're moving in the y direction, and we're gonna move 2 up. So if we have 0, 0 here, we're gonna move. If you think this is, it jumps in 2s, 2 and 4. So we're gonna go to here. And that will be our line of symmetry. So that's our first symmetrical line like this, and that will be the second. Oh my god! And that will be the second symmetrical line on that way. So if you redraw this like this, so the curve therefore is going up 2 units, and the 2 comes from there. So that point there is not gonna. It starts at 0, 0. The x this time is not affected, it will be 0, 2. So the x is not affected. If it's outside the bracket, you do not shift the x. So that's the first example. Now let's look at the second example we looked at, which was going to be f of x is equals to x cubed. We said that if we have f of x, it's good to always draw the original equation. Draw the original equations, and then we draw the other one. I'm just going to draw myself some axes so I don't have to redraw them. I'll be uploading these notes onto the school platform for you to look at, the exact notes that I'm doing now, because I've lost those notes, so I'm going to redo them for you. This will be all uploaded, don't worry. Okay, so the original equation in the question is f of x equals x cubed, and f of x is equals to x open bracket x minus 2. So x cubed, okay, x cubed is going to be the x cubed will always start from this side because it's positive, therefore it will look like something like that. Something like that, where this point is 0, 0. So now they want us to shift the x cubed by, if f of x equals x cubed, they want f of x plus 1. F of x plus 1. And we said in the question that should be g of x there. It's a different function. F of x plus 1. And how that looks like, guys, f of x plus 1 is going to be in the brackets, so that will be shifted in the x direction. So either can go that way or it can go that way, okay, in two ways only, not up and down. It's just held from, imagine pinching it from here and moving it to the left or to the right. But it says x plus 1, and we said anything in the bracket we do the opposite. Anything in the bracket we do the opposing translation. So it's x plus 1, we're going to shift it to minus 1, that way. So we look at this point, we said that because in the x direction it only affects the x, so therefore this there, it will be minus 1, 0. So minus 1, 0 is here, okay. So how would it look? It would look like something like this, and it'll just touch it like that and go back up. And this point is also important because it's shifted. If you think about it, x plus 1, if you do x plus 1 all cubed, you get 1 for this number here. That's 1. And that's my x, y, and x and y coordinates. So you can see it moves from 0, 0 to 0, minus 1. Minus 1, 0, sorry. So that is a function there. Now if I move and use this and say, what if I want to shift this curve x cubed by x cubed plus 2? It's outside the bracket. So this curve here is going to be not shifted to the left or to the right, it's in the outside the bracket, which means it's in the y direction. And you do exactly what it says, it's plus 2. So we're going to take this point and we're going to shift it 2. So you say this is 2 here, it's going to look like something like this. Okay, something like that. So 2 is where it crosses. I think about a curve, y equals mx plus c. Straight away we can take this 2 and plot it there. Quite common sense, I think. So now, if we look at the second function, if we say, actually, let's expand this understanding. Sorry, this video is going to take long. But y is equals to, okay, y is equals to x open bracket. If we say the f of x and this is going to be outside the bracket, inside the bracket, sorry, of minus 5. F of x minus 5. You know f of x is x cubed, which we have here, and we said that we're going to do minus 5, which means that it will be shifted here, it's in the bracket, so the x direction, and we said that therefore if it's in the x direction we do the opposite, so plus 5 would be something here. So if we draw this something like that there, it's being moved from 0 0 to 5 0, and it will cross at minus 125, and I know that because it's x cubed, so if I rearrange this to x minus 5 all cubed, then the x minus 5 will turn to become 125, and this is my glittery pen. So that is f of x cubed. Let's go to the next function, which is x open bracket x minus 2. So if we have our function here, and we said that we need to draw more lines, there we go. Line there and line there. Okay, so now let's look at the original function. So the original function, it is x open bracket x minus 2, that is g of x, that's just a letter. So x and x minus 2 means that it will cross at 0 and cross at x minus 2. So cross at x minus 2. Think if in our heads we say that, let's say this distance is 1, so this distance is 2, is going to be about here. That's too small actually. Let's say 2 is here. So the curve then is going to cross at 0. Okay, it's going to come like this, and then dip down and go back up. So this is the curve x minus 2. Okay. Now what we're going to do to this curve is that we're going to shift it first, g of x plus 1. Again, it is in the bracket, and it's plus 1. We're going to move in the x direction, and we're going to do the inverse. So we're going to move by minus 1. So minus 1 is that way. So then that means these 2 points are known. These 2 points are 0 0, and it is going to be 1, so 2 0. Because it's inside the bracket, it only affects the x coordinate. So that means this new one would be changed to minus 1 0. Sorry, it's by 2. I do apologize. So minus 2 0. Okay, we shift now. It's by 1. Sorry, it's by 1. So that will be minus 1 0, and this one would be 1 0. So we've translated these points. So because you translated this point, it's a matter of just doing them. So think about it, minus 1 being here and 1 being here. So you'll have a curve that goes like this, something like that. So the curve has shifted that way by 1 unit. And now we have a y-intercept, and we know the y-intercept is going to be x. The new points are going to be x minus 1 and x plus 1. So therefore, it's going to be here. Minus 1 as our y-intercept. How do I know this? Because it's x plus 1. We know that we have x by itself. This in essence, it should be x plus 0 and x minus 2, but we don't write plus 0. Okay, we leave it as normal x. So how do you convert this? We're going to shift it by 1 to the left. So it will be x minus, it will be x plus 0 minus 1, and here will be x minus 2, sorry, x minus 2 minus 1. So x minus 2 minus 1 will give me x minus 3. Yeah, so x, sorry, I do apologize, that one, yeah, so plus 1. That will give me x plus 1, and x minus 2 plus 1 gives me x and x minus 1, and minus 1 times minus 1 gives me negative 1. Now if we have for the last one, then we're going to go through the example we did on this video is getting too long, but we have to cover it on h of basically 1 of x, which is reciprocal function, will be the last function, and then I'll upload the video for you. So the last one, guys, thank you for holding through. Now the last one is going for this one will be g of x plus 2. Okay, I like to do minus 2. Now we have these points. The original points are 0, 0, and and 2, 0. Because it's minus 2, it only affects the y coordinate. So we're gonna minus 2 on this one and minus 2 on this one. Our new one would be 0 minus 2 and 2 minus 2. How would that look? 0 minus 2 is going to be here, and 2 minus 2 is going to go down to here. Okay, so if I extend the graph, it would look something, we can remove this now, it would look something like that. The curve would look something like this. There. Okay, so it would look something like that, and that because it's been moved down by 2 units, minus 2 units. So now let's look at the final example, example 3, and we said example 3, all these units, all these notes again would be given to you. All these notes here will be given to you. Sorry, my handwriting is atrocious. Now if we look at the curve, h of x is equals to 1 over x. We said that before, that if we draw this, it would look like something like that. Where we have our asymptote, that means this line would never meet the curve. So the curve would go get really close to it but never meet it. So now if they told us to shift this by h of x plus 1, that means it's outside the bracket. That means this is going to happen outside the bracket, which means to us as you know, as mathematicians, that it's going to be a y direction, and we do exactly what's on the tin. However, what happens when you have reciprocal functions, the curve doesn't really get changed. Okay, what changes is the asymptote. So if I draw our line, so before this was our asymptote, okay, because the curve can never touch it. Our new asymptote is going to move up, okay, by 1 unit. So this is our new asymptote. Now what that means is that the curve can now get really close to this point of this line and never touch it. And similarly here, this point can get really close and never touch it. Okay, so this is the point 1, and that's what you have to plot. The examiner doesn't care about how accurate you draw these. Most importantly, is the asymptote in place, and is the shape on the right side? Because if he has a minus 1 over x, it starts from here. Okay, minus 1 over x starts from here. So let's try a different one. Let's Okay, this is this function x plus 1. Let's drop this out. Let's try something else. Let's try, for example, h of x minus 2. So we know the original equation, the asymptotes start here. Now because we're going minus 2, we're going to go 1, 2 spaces. So our asymptote is going to start from there. If we label it as minus 2, then our asymptote is going to come like this. Now our curve therefore is going to be coming down and going there, and the curve at the top now is going to cross the x-axis and get close to this dotted line and never touch it. It's going to get really close but never touch it. So this is where I'm gonna stop. I hope this helps you to study, and in lesson we're gonna move to stretching graphs and transforming them.